Thank you. And Helen, you really are the reason we're all here today. Without you organizing this, we just wouldn't be here. So thank you. Thank you all for joining. I'm Adam Shostack, and I'm here to talk to you about publishing your threat model, how and why you should do that. And, by way of introduction, I do a lot of work in threat modeling, including writing 2 books on the subject, creating a card game to help people threat model some of the earliest software for threat modeling, and I advise company Arius Risk in this space. Also, in my career, I've been privileged to help create the CVE. I'm on the review board for Black Hat. I am an affiliate professor at the University of Washington's Computer Science School. And in my day job, I run a consulting firm, Shostack and Associates. We help enable threat modeling for our clients. And as I said, today I want to talk to you about publishing your threat models. And I want to start by saying that threat modeling has been something that we've been doing in technology for a long time at various levels of formality. And I'll talk about what threat modeling is, but the core of threat modeling is simply asking what can go wrong. And if you don't ask what can go wrong, you're not really doing great engineering. When we do something more structured in a threat model, whether that's writing it down, having a conversation about it, this record, can explain your security understanding, the decisions you're making, the properties you're pursuing to the people who rely on your project, to the people who contribute to your project. And so publishing your threat models really aligns with openness. It aligns with secure by design and secure by demand. And so over the last few months, I've been working with Lauren Konfelder on a paper titled Publish Your Threat Models. If you don't know Lauren, he's been in security for long enough that he was able to design public key infrastructure. The whole idea of cryptographic certificates comes from a paper of his. And he also, in security, created the stride mnemonic, which some of you may know. You may use it in threat modeling. And so I'm excited to share this work. And this morning, in fact, Archive let me know that the paper version of this is available. And I will say, since there's URLs here in these slides, let me just say right now, these slides will be published. They'll be available in addition to the recording. And so before I even get started, when we say publish your threat models, there's a whole bunch of people in the commercial world who have a very visceral response to that. It usually involves a swear word or two before the word no. And I'm just going to assume that the open source community doesn't have that response because, well, you do open source. And so if anyone is having that sort of, we couldn't possibly do this sort of response, I'm happy to talk about that during the Q&A, but I want to talk about what I believe are more important challenges and questions for your community as you run into this idea. And so there are published threat models, and this one from Curl was actually based on a OSTIF funded security audit, and they published how they thought about the security of Curl, and it's pretty cool. So getting through those preliminaries, getting past those preliminaries, what I want to talk about today is the world of open source and security analysis. What is threat modeling? And then, and I'm going to spend most of my time here, why don't we have more threat models for open source projects? So, first and foremost, publishing threat models is aligned with open source. Your projects are open, you can't hide secrets in the code, you can't really rely on no one will notice. Um, and so I think there's a strong alignment, and Derek talking about this in chat. So the first thing, and Derek mentions this, most open source projects want to publish. Open source does eliminate many barriers to security analysis. It eliminates the need for permission, it eliminates the need for NDAs, it eliminates the need for reverse engineering. All awesome. But reading and understanding code is actually a lot of work. The comments, which might tell us what someone was thinking, scattered around, they're out of date. A lot of the design choices happen in discussion on mailing lists, they happen in discussions on Slack or Discord, and so they may be implicit, even though they're in the code, they might not be easily linked to the code or from the code. I might not know which GitHub issues to pay attention to. Similarly, there's not a lot of explanation of the operational process in the code. If I'm going to use this library, how do I do so safely? And this leads to a disconnect between people who are looking at your project and the people who are creating it. And my friends who manage projects tell me they get lots of bug reports about things they don't think are bugs. And I think threat models can help. So now that I'm saying this, I want to quote from an academic paper. This was at Usenix 2025. Threat modeling is very formal, it's very technical, and also very hard to do correctly. And this was an interview study focused on open source maintainers to understand how open source people thought about it. And so I want to talk about these objections, or these, I shouldn't use the word objections, these perceptions. And the first thing I want to say is these perceptions are real. This is how the interviewees felt about the things to which they were. This is how the interviewees felt about threat modeling. I'm not challenging these perceptions. But I want to say there are other ways we can approach threat modeling, which make some of these things easier, which make some of these things less formal, less difficult, because I believe the folks who were saying those things probably believed that that was all threat modeling. And I really do see threat modeling as a big tent. There's more than one way to do it. And if we do it in ways that align with we can choose ways that overcome these sorts of issues. So, what is threat modeling? I've been talking about it. Let me get concrete about how it works. And this is my standard introduction. This is what I tell everybody. It's not customized for the open source world. And I mention that because I really see the practices covering both proprietary and open projects. So what is threat modeling? It's using models to think about threats. We're abstracting, we're throwing away some details so that we can model, and we can work with that model more easily than we can work with all the messy, complicated details. When I say threats, what I mean is possible future problems, from it threatened terrain to nice store you've got here. It'd be a shame if something were to happen to it, which is a threat that if you don't pay protection money, the store will get firebombed or what have you. And And that's important because oftentimes a threat is accompanied implicitly or explicitly by a defense or a mitigation or a thing we can do to lessen the future problem. Threat modeling applies to both the systems you make and the ones you deploy. So a lot of people think of threat modeling as either operations focused or software focused. I think the same approaches, which I'll talk about in just a second, work for both. There are two sayings I like to use when I'm talking about threat modeling. The first is measure twice, cut once. And if you're doing you're working in a wood shop, say, you measure twice because otherwise you have a pile of wood over in the corner, which is waste. And in software, that waste is less visible, but it shows up in rewrites, it shows up in flame wars on mailing lists, it shows up in arguments that you can avoid by thinking through what you're doing, getting agreement on it, and then ensuring that everyone understands how you're doing security. The second quote, which is from architect Frank Lloyd Wright, you can fix it on the drawing board with an eraser or on the job site with a sledgehammer. Threat modeling is the eraser of software. It allows us to fix the problems when things are still on the drawing board, when the code hasn't been written, and it's amazing for that. So, how do we do it? We ask four simple questions, and those questions are: what are we working on? What can go wrong? What are we going to do about it? And did we do a good job? These questions are in the Threat Modeling Manifesto. They're in a white paper that you can get for free off of our website. They form the core of my books, and I am happy to talk about how to threat model. But I'm just going to give you a couple of examples as we go, just to make this concrete. So these questions enable scenario-specific ways of answering the questions. And when I say that, the way in which we think about, for example, a piece of hardware that we're threat modeling, we might show it, we might represent it differently than a bit of software. We might use different types of diagrams, we might use different analytic techniques. But these questions enable us to have conversations. The other thing I want to mention is that threat models enable us to think about boundaries. They let us think about what code can influence what other code. And boundaries are incredibly powerful when we rely on them to ensure that code doesn't break other code. And the more boundaries we have, the better off we are. And threat modeling gives us a chance to think about where those boundaries are, could be, or should be. So when we get to how do we answer the question, what are we working on? We can answer it with a whiteboard, we can answer it using Legos. No, really, I'll show you in just a second. We can answer it with data flow diagrams, which are commonly associated with threat models. When we say what can go wrong, we can simply ask that question. We can use a mnemonic like STRIDE. STRIDE stands for Spoofing, Tampering, Repudiation, Information Disclosure, Denial of Service, and Expansion of Authority. I have to say it a lot. We can use kill chains like MITRE ATT&CK or MITRE's Atlas, their analysis of AI. And so we can use these different techniques when they're appropriate to help us figure out what can go wrong. So when we get to what are we working on, some folks at the W3C actually used Legos to represent things, and you can see here that they were building a visual representation of discriminatory vetting processes based on individual characteristics. And I just love this, and you can find the W3C blog post about this. We can also use use a simple diagram like this. And so this data flow diagram shows a IoT camera, which is, it has a kernel, it has a camera app, maybe it has an app that connects via Wi-Fi, there's a browser, might connect to a user interface in the cloud. And this version of the camera system has pretty lightweight security. We could add a little more security by adding some boundaries. So these dashed lines here are boundaries, and we could say, we'll put the UI under one user ID, the business logic under a second, and we'll run the updater under yet a third. We can also divvy things up in the cloud so that an attacker who is taking over one part of the system has more work to do to attack the rest of it. And these sort of simple diagrams are incredibly communicative. They are really helpful in helping someone understand, okay, here's what this thing is or does. All right, so with that, I want to, so there's my quick introduction to threat modeling, and I want to transition to talking about threat modeling in open source. So, a threat model document is the primary record of security analysis and decisions. It's just sometimes, maybe even often, informal, or it's secret in closed products. Sometimes it's integrated into design documents, and these things might discuss trade-offs. We chose to do A, not B, because B has this impact. We might choose to do this, or we might know about issues. We might know that there are limits to our security as a result of a design choice that we've made. We might know about known failings. Whatever the state of your projects are, I really believe that threat models are the best way to talk about the security of your system. Now, I want to come back to this paper. I want to come back to this perception that threat modeling is formal, technical, and very hard to do correctly. And when we say it's very formal, I mean, look, here's a NIST cybersecurity white paper for a genomic data sequencing machine, and it's 64 pages long. That's a lot, right? But also, there was a Signal blog post a month or so ago where they talked about what the threats were to the Signal messaging app. And they said things like, consider this case. Send a key if you haven't sent one in a week. What can go wrong? Bob might be offline for a couple of weeks. So what does Alice do then? What happens if we lose messages and we lose the one that has a new key? Or what if there's an attacker in the middle? This analysis, even though it's written up in a less formal thing than a 64-page NIST PDF, is absolutely a set of people expressing answers to the question of what can go wrong. And they're listing things. They're listing them as what happens if, what does Alice do? But these are examples of what can go wrong in a much less formal setting. This very technical, this comes out, this diagram, that's the word I want, this diagram comes out of that same blog post. And yeah, this is in fact a little intimidating. I buy that. And Signal really went through a 5,900 word blog post. And what are we working on? They're working on post-quantum cryptography and messaging. There's lots of things that can go wrong with it. And what they're going to do is what they call a triple ratchet algorithm. And they have a whole section of their post in which they evaluate the question of, did we do a good job? And this sort of published threat model is absolutely a standard in the world of cryptography. Um, Cryptographic papers going back to the RSA paper or the Diffie-Hellman paper examine the threat model, examine the question of what can go wrong, and what they're going to do about it within that algorithmic system. And so we get the objection, or we get the concern's a better word, that threat models are very technical. It's true, they are. But in a sense, so is writing code. Writing code is a pretty technical task, and people do it for all of the reasons that people contribute in the open source world. And so I want to encourage you to look at the need to threat model and or the goal of threat modeling and saying, wow, that's very technical. Some of you are paid, some of you are hobbyists in a very technical field. And let me give respect to the person who answered that question and said threat modeling is very technical. I don't think that's what they really meant. I think what they really meant is threat modeling requires a different set of technical skills than I have, and I feel intimidated by it. And that's legit, I get that. And the question we ask in threat modeling is not, how does MITRE ATT&CK T1007 apply to this design? It's what can go wrong. And when we phrase it as what can go wrong, and we don't require these crazy complicated technical answers or these crazy complicated jargonified answers, it becomes easier to engage with it in the same way that you engage with other technical demands of the work that you're doing in your projects. Lastly, the last objection in that headline is it's very hard to do correctly. Okay, I get that you feel that way. And the question I want to ask is, and this is actually an open question, and Tom or Derek, I wonder, actually, I should have set this up as a poll. Can someone who's a co-host see if we can do a poll for this as we're doing this? Should have thought about this, sorry. But is the challenge security? You don't know enough about security and you're afraid to write things down, concerned about writing things down? Is it threat modeling is very hard to do right? Is it you have some aspiration as to what the documentation ought to be, and therefore you're afraid to do the work? Are we letting the perfect be the enemy of the good? Where we don't want to do an okay threat model, security is important, we want to do a great threat model, or is it something else? And if it's something else, I would really love to know what makes it hard to do threat modeling right, so that we can help address it as a community, enable you to threat model, and get those threat models out there into the world. All right, I don't think we're going to have a poll here, but I would love to hear your answers in chat or in questions later. Ooh, Corey. Corey says culturing others to consume the model, build with it, and ensure it remains a living asset. Love it, thank you. All right, and our lovely hosts are saying we need to have thought about that. What can go wrong? We don't think about enabling the poll feature. What are we going to do about it? Lesson learned for next time. See, threat modeling can be simple, easy, in the moment, rather than a big, complex 64-page PDF document. There's two other quotes that I wanted to bring in. One said, what I find challenging sometimes is figuring out how to convince other people that the threat exists and needs to be taken seriously, which is an issue. Um, and I love this. And the thing I want to say about participant 15 here is if there's disagreement about what threats you're working on, maybe participant 15 is doing some work to defend against a threat that some other participant in the project isn't working on, and that lack of alignment has some cost. Um, and participant 16 said, when talking about the mitigations, if there's contention about this, it takes a long time to make the decision, especially if the answer is no. And when I read that, what I take from this is participant 16's project cares about security. They want to deal with the problems that they discover, but there are some which, for whatever reason, are difficult. And some of these reasons for security being difficult will often involve API compatibility, they'll involve usability, um, they'll involve feature functionality trade offs. And so we don't want to say no. But getting to clarity about what you're building is really valuable. And in any case, if there's a disagreement about a threat and you decide not to do something about it, telling people we thought about this and we decided not to do anything about it is the sort of transparency that I hope for from everyone. So, do we need full transparency? For commercial vendors, the threat model might be a subset. When you get into system models, they might focus on the internet facing parts, what we sometimes call the attack surface. And that internet surface is definitely a boundary. It's often one of many boundaries. And for commercial products where we don't expect people to modify the non-user serviceable parts inside, those details might confuse people rather than illuminate things. And so leaving those out might make sense for might make sense for commercial projects. I think it makes less sense for open source projects. And the other thing is, which threats do we include? I really think it's great to show all of the threats. If you've addressed a bunch of things, explain that. Good on you. It demonstrates that how you thought about it. It demonstrates that you're taking responsibility. Also, there's many threats that you expect operators to manage, right? If you've got an open source project, you're not collecting the logs in all likelihood. That's a thing that your end users need to look at. And there are also things that might be by design, they might be accepted. Tell people what those are. And really, I believe that publishing a subset of your threat model, only talking about some of your threats, starts to look a lot like security by obscurity. Oops, I hit the wrong button there. So, I'm going to close up in just a minute, but I want to encourage you to publish your threat models. It's good for you, it's good for your customers, it's good for your community, it's good for the world. And really, if there are barriers, I'd love to understand what those barriers are so that we can help you overcome them and see more threat models in the world. So with that, want to encourage you to publish your threat models. Again, the core argument is here. I have not quite gotten the slides onto my blog. They should be there late today Seattle time. So I have a few hours